Hello guys, welcome to the channel again, Safas, Center for Learning. In the last class we discussed about the interior of the earth, the part 1 and part 2, and we'll discuss about the structure of the earth right now in this class. So when we talk about the structure of the earth is divided into three parts. One is crust, another one is mantle, the last one is core. The crust is further divided into oceanic crust, and continental crust. This dividing line is called Moho discontinuity between the crust and mantle. It is called Moho discontinuity. Okay, the boundary line between the crust and the mantle. And the mantle, there you can see the asthenosphere. Sorry, this is called asthenosphere. From here to here, the lithosphere. And the 0 to 20 kilometers, you can see the asthenosphere also. So again, the core is subdivided into two parts: outer core, inner core. Okay. So let's discuss one by one. Structure of the earth. Structure of the earth, the first one is the crust. Crust is the outermost solid part of the earth, and it consists of two types: oceanic crust and continental crust. Continental crust is thicker than the oceanic crust. So if you see the density difference of continental crust and oceanic crust, so the continental crust is 3 gram per centimeter cube because it is having the rocks, whereas oceanic crust is 2.7 gram per centimeter cube. Very important, remember. I'm talking about the density. Density is nothing but mass per volume. That's why I represent in the gram per centimeter cube. Okay. So oceanic crust is thinner and the continental crust is thicker. Though it is almost spreads across 30 kilometers, and oceanic crust spreads across 5 kilometers. Okay. Now let's come to the mantle. If you see the mantle, I'm talking about the mantle. This is crust. Let me use another colored pen so that it will be easy for you to remember. This is crust. Now I'm talking about the mantle. Okay. In the mantle, the topmost layer, almost 0 to 400, okay, 0 to 400 kilometers, that appears as a asthenosphere. The first 0 to 200 is the lithosphere. Okay, let me tell you about this. If you see this diagram closely, so this diagram, where you can see that this is continental crust, this is oceanic crust. Okay, oceanic crust 5 kilometers depth, whereas the crust, continental crust is 0 to 100 kilometers, around 30 kilometers. From 0 to 100, it is a crust. After 0 to 100, the 200 kilometers, from 100 to 200, you can see that lithosphere. From 10 to 100 only you can see that lithosphere. From 0 to, from the lower mantle, starts from the crust where it ends and starting of the point, and this point till now we call it the asthenosphere. Okay, this asthenosphere is the upper portion of the mantle. This asthenosphere is the upper portion of the mantle. And what is meant by astheno? Astheno means weak. That means it appears where it is the main source of magma. Magma means in liquid position, it is the main source of magma. Remember, asthenosphere is the main source of magma. It is the upper portion of the mantle. Okay? Okay. The lower mantle extends beyond the asthenosphere and it is in a solid state. Okay? So the mantle you can still from the 900 kilometers. From 100 to 200, 900 kilometers, you can see the mantle. So I'll tell you, listen, first 100 kilometers, 0 to 100, it is a crust. From 10 to 200, lithosphere. Whereas from 200 to like 400, 100 to 400, you can see the asthenosphere. 100 to 400 asthenosphere. So from 400 to 2900, it is total mantle. Okay. Now 2900 to 5100 kilometers, it is core. The total 2900 to 6378 kilometers total is core. The core is further divided into inner core and outer core. Okay, the core mantle boundary is located at the depth of 2900 kilometers. This is the core boundary. The outer core, this core is in liquid state and the inner core is in solid state. Why is it this one is in a liquid state, this one is a solid state? It's because of the pressure and temperature differences happened in the depths. Okay, and the core is mainly made up of heavy material, that is nickel and iron. Simply we call it as knife. Nickel is Ni, ferrous means iron. Okay, let's talk this one in a glimpse. The first one is a crust. It is outermost layer. Oceanic crust is thinner and thickness is 5 kilometers, made up of silica and magnesium. We call it as SEMA. Oceanic crust made up of SEMA. Remember, oceanic crust silica and magnesium. Silica means sand, remember like that. Okay, whereas the continental crust made up of Sial. Si means silica, Al means aluminum. Okay, this one is a very much thicker than this one. This one is 5 kilometers thicker. This one is 70 km, 30 km to 70 km. Okay. So next, lithosphere. This is the outermost layer of the mantle, and it is spreads across 10 to 200 kilometers. Okay. So after that, there comes a mantle. So that this region, mantle, extends from the Moho discontinuity to a depth of 209 kilometers. Moho discontinuity means that is the boundary line between the crust and mantle. Okay, this is the boundary line between the crust and mantle. This is the core, this is mantle, this is crust. Okay, and in the mantle you can see the upper portion of the mantle is filled up with asthenosphere, that is nothing but till 400 kilometers. This asthenosphere is mainly useful for the, there you can find the magma, the liquid position. Okay, so that is what. So let us discuss about the boundaries and discontinuities between the earth layers. The first one is conodiscontinuity. C-O-N-O-U-R-E-D, conord discontinuity. It is between the upper and lower crust. Okay, it's better, I think I have to draw. Let me draw a diagram so that you can understand clearly. crust, mantle, core. The first discontinuity between the upper and lower crust. Let us take this is the upper crust and this is the lower crust. This boundary called Carnot boundary. Discontinuity. Whereas Mohodioic discontinuity, Moho discontinuity we call it as, it is between the crust and the mantle. This is called Moho discontinuity. Next, Repetit discontinuity. It is between the upper and lower mantle. Let us take this is upper and this is lower. This discontinuity called Repetit discontinuity. Next, Gutenberg discontinuity. It lies between the mantle and outer core. It is called outer core, inner core. Okay. This one is called Gutenberg discontinuity. Okay. Lehmann discontinuity. Lehmann discontinuity is the between the outer and inner core. Okay. These are the boundaries very much important for the APPSC group and UPSC purpose. Okay, discontinuity. First one, upper and lower crust between the Carnot discontinuity. Between the upper and lower mantle, there is a Repetit discontinuity. Between the crust and the mantle, Moho discontinuity. And between the mantle and the core, there is a Gutenberg discontinuity, mantle and outer core. And between the inner and outer core, there is a Lehmann discontinuity. Okay. So these are the boundaries. Moho discontinuity, Gutenberg discontinuity, Lehmann discontinuity is very important. Okay, between the inner and outer cores. This is the Lehmann discontinuity. Gutenberg discontinuity between the mantle and the core. Okay, let's talk about the next part. Volcanic and volcanic landforms. So volcano. Okay. So volcano is a place where the gases and ashes and molten rock material escape to the ground from the earth interior. So mainly from the asthenosphere. As we discussed that asthenosphere is the main source for the magma. So volcano is nothing but the eruption or the place where the gases and ashes coming from the earth interior, from the earth surface to the earth surface. So this point is very important. The material in the upper mantle portion is called magma. But when it comes to the surface, it's called lava. Inside the volcano, it is called magma. Outside the volcano, it is called lava. That is simply explanation for the what is magma and what is lava. So volcanoes are classified into further different forms based on the nature of the eruption and the form developed at the surface. Form means in which form they are looks like. Shield volcanoes. The first one is shield volcanoes. So they are the largest of all the volcanoes of the earth and they are made up of basalt. Okay. And they looks like a forming of shield, just like a first warrior of America soldier, no? American soldier. Okay, it's like looks like a shield. They are not steep at all. Okay, and they are characterized by the low explosivity. That means a very low explosion. You can see near the shield volcanoes. And whatever the lava coming from this volcano, they forms like a fountain shapes and forms like a cinder cones. See that the cone shape you can see over here, just like this. Okay, this is called the cinder cones. Okay, the remaining forms of volcanoes we'll discuss in the next session. Thanks for watching. Please watch it and support. We'll come into the more sessions like this. Thank you very much.